In the last two videos, we've been talking indirectly about the perpendicular bisector of the line segment. And we've developed enough clues through our inquiry experiment that now we have the ability to construct the perpendicular bisector without any experimentation at all, using a compass and a straight edge. Let's take a look at how that works. So here I have a line segment AB, and I've got the line segment drawn. And so what I'm going to do first is, like we did in the experiment, we want to find points that are equidistant from A and B. And so what I'm going to do is I'm going to open my compass more than halfway across that line segment. And I'm going to draw a couple arcs. I'm going to make these arcs pretty big in the beginning. But as you get more and more experience, you're going to be able to kind of home in on the exact points where you expect your answer is going to lie. So I didn't change the length of the compass at all. So now I'm going to put the center of the compass at B, and I'm going to draw arcs to find those intersection points. Now let's think about what these intersection points mean. Since I didn't change the size of the compass, I know that this distance and this distance are the same. So this point is the same distance as it is from A as it is from B. And so is that. Well, what else do we know about the perpendicular bisector from our experiment? Well, we know that the perpendicular bisector is a straight line. And as long as we know 2 points that are on a line, we can find the entire line just by connecting those 2 points. That's going to be the line we're looking for. So I take my straight edge. Remember, in geometry, we're not using our ruler very much for measuring things. We're using it almost exclusively for just drawing straight lines. All right, and so now I drew that line segment. So let's take a look at what we've got there. So this line segment, just like we saw in our experimental picture, all the points on this line are going to be the same distance from A as they are from B. Let's take some experiment points and kind of see if I can verify that. So this point is this far from A. Squeeze it in there, and moving over to B, I see, yep, it's that same length. All right. So just finding 2 points that are on that line and then connecting them gives me all of the points all together. And so I can see, first of all, that this is going through the midpoint of AB. Yep. So this construction did create something that goes through the midpoint. So this is a bisector. And also, if I took something that I expect to be a right angle and hold it up there, I can see that, lo and behold, it matches up exactly with that right angle that I expected to see. Now, maybe if I pulled out a protractor and measured this precisely, I might find that it's 89 degrees or 91 degrees, but that doesn't particularly matter. I mean, I might have made a few mistakes when I did my construction. You know, my compass might have slipped a little bit, or my, the line that I drew with a straight edge might not have been precisely through the center of those 2 points. Now, when you do a construction, there are some really important facts. The first thing you might think when you come across this and say, okay, I wanted to create the perpendicular bisector, so these points here, these little scratch marks, I should get rid of them, kind of clean up. No, don't do that. When you're doing a geometric construction, these arcs and the supplemental line segments that you come up with, these are kind of the receipts that prove that what you did this using a compass and a straight. So that means that what you're doing is precisely right. If you just kind of eyeballed it and said, well, here's my line segment, so I think that the perpendicular line sector is going to be, something like this. And okay, I know Mr. Daly wants to see some of these things, so I'll do that. that's not going to fool anybody, I'm afraid. I can point you to some students last year who thought they could do that and convince me that they moved those marks with an actual compass. But no such luck for them. So when you do constructions, do be aware that you should actually use a compass and a straight edge. If you haven't bought one yet, you need to get right on that, because one of the homework assignments I'm going to give you is to draw a line segment and bisect it using a compass and a straight edge, and send me a picture of it with all of the construction marks on it. Okay, so that's going to convince me that you're doing the work. And yes, I am going to look at that picture and I'm going to pull out my own compass and I'm going to verify your marks. That's what they're there for. So please don't try and pull one over on me, because that's going to be hard on both of us, especially when it comes time to do this on the Regents exam, when people are going to be looking at this and giving you an honest grade on it. So that's the notion of the perpendicular bisector. It's a pretty easy construction to do, but it's so key to what we're going to be doing. Really, quite a few of the additional constructions that we're going to need to do before we're done are based on this perpendicular bisector construction. So go through and watch this video as many times as you feel you need to. Do a lot of practicing on your own on scrap pieces of paper with your compass and straight edge, and you'll be a pro at it in no time at all.